Lesson 4-1, Inequalities and their graphs. The solution of an inequality is any number that makes an inequality true, just like a solution to an equation is any number that makes an equation true. Equivalent inequalities are inequalities with the same solution. For example, x plus 4 is less than 7 is the same as x is less than 3 because they have the same solution. Any number less than 3 will be a solution to that inequality. Inequalities and their graphs. One of the most important things you need to be aware of is an equal sign is a mathematical way of saying is. An inequality is a mathematical way of saying other things. For example, if I was to say I have less than $5 in my pocket, you would not want to name all the possible money combinations I have in my pocket. You would not want to say, well, Mr. Sheehan could have $4.99 or $4.98 or $4.97, $4.96, all the way down to $0.00. So we use inequalities to do that. The first symbol here is greater than. The second symbol, when it's pointing to the left, is less than. If you put a line underneath the greater than symbol, that means it's greater than or equal to, otherwise known as at least. Okay, it's a very important phrase. This is the same thing as saying at least. If you put less than or equal to, it's the same thing as saying at most. The next thing we're going to do is look at how can you tell if something is a solution to an inequality. You're simply going to...
Gary, please go to the room.
If we're going to see if a number is a solution to an inequality, you simply need to plug the number in to see if it makes a true statement or not. For example, if I want to see is each number a solution if x is greater than or equal to 5. So we want to plug in -2 for x. So -2, is that greater than or equal to 5? No, that is not greater than or equal to 5, so -2 is not a solution. If I look at 10, 10, is that greater than or equal to 5? Yes, it is. 10 is greater than 5, so yes, 10 is a solution to the inequality of x is greater than 5. We can look at it a little bit more complex when there's two-step inequalities. All we need to do again is plug the number in, work through the formula to see if it works. So if we have 3 plus 2x is less than or equal to 8, and we want to know if -2 is a solution to that, we will put in 3 plus 2 times -2 less than or equal to 8. So we've got 3 plus -4, is that less than or equal to 8? 3 plus -4 is -1. -1 is less than or equal to 8. So yes, -2 is a solution to this inequality. If we plug in 3, we have 3 plus 2 times 3 is less than or equal to 8. So 3 plus 6 less than or equal to 8. 9 is not less than or equal to 8. So no, that is not a solution to the inequality. If we put in -9, 3 plus 2 times -9, is that less than or equal to 8? 3 plus -18, is that less than or equal to 8? Well, -15 is definitely less than or equal to 8. So yes, -9 is a solution to the inequality. All you have to do is plug your numbers in, work through the math, to see if it makes a true statement or not. You can graph inequalities to indicate all of the solutions as well. If a number is a solution of an inequality, be sure to use what we call a closed circle. If a number is not a solution of an inequality, be sure to use an open circle. A closed circle looks like this. An open circle looks like this. You use a closed circle when it's less than or equal to or greater than or equal to. Use an open circle when it's less than or greater than, no equal to. So if we need to graph D is less than 3, all we need to do is make a number line, and of course you have to put enough numbers on the number line so we can clearly see that you know how to do a number line. Okay, here's 0. 1, 2, 3, 4, 5. I'm going to put +5 here. 1, 2, 3, 4, 5. Put -5 here. If D is less than 3, 3 is here. It's an open circle because it does not include the number 3. And it's all the numbers less than, which goes this way. A really nice clue is if the variable is given first, the inequality symbol should point the same direction as the graph. That only works if the inequality is given, if the value, if the variable is given first in the inequality. If we look at number B, or letter B here, -3 is greater than or equal to G. I'm going to rewrite this so that G comes first, because it's always better to write it with your variable first. So this would be G. Notice how it's open toward the -3 and pointing toward the G. So I need to point toward the G, make it open toward the -3. So G is less than or equal to -3. So here's my number line. There's my labeling of my number line. Now I simply just need to plug it in. It's less than or equal to -3. So I will find -3. I will make it a closed circle. And I will go less than, which goes to the left. I like to graph above the number line because it's clear and easy to see. If you graph on the number line with a pencil, sometimes it's very difficult to see where you're going and which direction you're going. Last one here, 1.5 is greater than P. I'm going to rewrite it. P is less than 1.5. Okay, close toward P, open toward the 1.5. Points toward P, it's open toward the 1.5. Draw my number line. Still going to graph by ones. Go to 1.5. There's 1. 1.5 is right here. Open circle and a line that goes to the left. Just make sure you know when to use a closed circle, when to use an open circle. A closed circle you use when it's greater than or equal to or less than or equal to. An open circle is when it's greater than or less than. Now, you can write an inequality for a graph by simply reading off of the graph. And it doesn't matter what your variable happens to be. You can choose whatever variable you so desire. So if I told you to write an inequality for each graph here, on this first one here, we can see that it starts at -2 and goes to the left, which means it's less than. Makes it much easier to write this if you do put the variable first. It doesn't matter what your variable needs to be. I'm going to use X. X, whoa, let's not use highlight. X here is going to be less than, but since it is a closed circle, I need to put the bar underneath it, so it's less than or equal to -2. And that's all you need to do there. If we look at this next one here, it goes off to the right, which means greater than X. Notice it's an open circle. Since it's an open circle, it's just greater than -1. Simply put, it's not too hard to graph things from a number line. And the last thing we need to do is be able to define a variable and write an inequality. So it says a speed that violates the law when the speed limit is 55 miles per hour. First thing you have to think about is what speed would violate the speed limit? Well, if the speed limit is 55, what would violate it would be anything over 55 miles per hour. So I'm going to let X equal the speed. So anything over 55 miles per hour. You can drive 55 and still be within the limit, but you can't drive 56. So it's not a greater than or equal to, it's just a greater than. It would be X is greater than 55. We look at the second one, a job that pays at least $500 a month. At least means no less than, so it's got to be $500 or more per month. So I'm going to let M equal the amount of money. So M has got to pay at least, which means greater than or equal to $500. And you can leave the dollar sign off because you're just writing an inequality. So you need to define your variable and write your inequality.